the topic of today's programming lecture is variables, and then a concept called branching, having a program do one thing or another thing. Okay, so variables, first of all, you've used them in math by now, right? A variable is just a name that can talk about some other thing. In programming, it's just like we call something X, and we can put inside of that thing, we think of it as a box, the variable in computer science, and it can hold stuff for us. Like we can put 42 in the box, and then instead of saying 42 all day long, we can just say X now. It's like it's referencing the idea of holding 42. So we're assigning something into a variable, that's a possibility. And yeah, all this stuff will be on Scratch today. So if you'd like, we can go to scratch.mit.edu and just search for it on Google. It'll bring it up if you forgot the link. But start creating is where we want to be today with our good old friend, the Scratch Cat. All right, so yeah, I guess I want to start with variables because those are very important. They're ways to like store information. Another name for stuff that you don't want to type too much longer. So yeah, it's just great. So in general, a variable is just a box for us. It's just a box. It holds stuff. You can put stuff in the box, retrieve things out of the box. You can mess with the contents as well. So like you can store 1,234 in a variable called X because X is shorter to say. You don't have to be typing 1,234, right? And that's super nice. And then you can use that. In addition to just saying X, you can use it in Scratch and be like, hey, give me the value, compute the value of like X plus 1. Math on it now, which is extra nice, right? You just like shove something in X and then use it with bigger things. So that's useful. Yeah, eventually we'll get like input from the user to make our programs cool and different every time. We'll like ask the user, hey, give me something, and they'll type whatever they want, and we can do math with whatever they give us if we put it into a variable, right? That's perfect. It's like we can say, all right, come along later and say their input times 2 or something. If we shove things into a variable, even if it's something for the user and we didn't know what it was, we just used the variable's name, and now suddenly we have access to it. It's very nice. Okay, so with that in mind, let's make this program. Let's make a program that asks the user for their name, because you can type a different name every time. It'll be a different program, right? And it will respond, hello, your name. Okay, that's going to be our goal. So let's see here. I guess the first thing I want to talk about is the idea of text in Scratch or in just programming in general. So we want to like spit back out after we get the person's name. Like we'll store it in a variable called like answer or something. We're going to get their name. Like if I type my name, it'll go here into this answer variable. And it goes in as something called a string. All right. So when you have text data in programming, usually I use double quotes to mean that. It's called a string. Right? It's a weird word. Just it means text inside of a program. All right. We call it a string. Think of it like the beads on a friendship bracelet that are made of characters, right? Something like that. That's how you can remember it. But yeah, just text in computer science is called a string. So like if the user types their name, we're getting their name as a string of characters. All right, it's just a bunch of characters. And there's a huge, huge difference between the string that holds 1, 2, 3, because that's just the character 1, the character 2, the character 3 typed in with no meaning. That is absolutely not the same as the number 1, 2, 3. So there's like a type difference, if that makes any sense at all. This will become more apparent later. I just want to plant the seed in your mind right now. Right? So strings are just text. They have no real meaning. It's just like these characters in this order, but those are completely different than numbers. Right? That makes a little bit of sense. I'll show you examples of what that means. So in general, what we want to do for this program is spit back out the string, hello, comma, space, and then put their name in that part. Okay, that's what we want. So we're computing strings. And so yeah, another idea here is like the difference between these have to do with an idea of a type. All right, so the type of this thing is a string, the type of this thing is a number. That'll become even more apparent when we talk about Python. And those types tell you what you can do to your variables that hold those types or just anything with them. All right, so like numbers, what can you do with numbers? Think about it. What can I do with a number? The number 123. I can like do math, right? Multiply, add, all that fun stuff. What can I do with strings? Not multiplication, not adding, right? You can do other things. There's ways to like print out strings. You can't do that with numbers very easily. Print out strings. You can join together 2 strings. I'll show you that. It's really nice. I'll just jumble them both together. So there's different things you can do to different types. All right, so I just want to say that now. I know it's not going to make enough sense until I give you an example. So here's an example of doing string stuff. Right, so let's make hello, comma space, your name using some blocks here. So here's my favorite character, the Scratch Cat. What I'd like to do is show you the join block first. So the join block is going to combine two strings. So I go down here, it's in operators, it's in green. It's down here somewhere. Did I miss it already? So here's join. You see this block? Let me zoom in. So it says join apple and banana, and you click it. You can click it to run it, and it will produce its answer. It gives back apple space banana, because secretly it's apple space in the first one. Apple space and then banana. So joining those two strings computes a bigger string, apple space banana, total. Does that make sense? That's what's going on there. All right, so it's computing a bigger thing. It's combining characters, the individual characters of the two strings that you give it. All right, so I'm going to put hello in the first one for sure. All right, so yeah, let's make a real program now. So when the green flag gets clicked, this is not like something that I can use yet, this little join block. It has to be part of something bigger. So it's circular. It's not like a Lego brick that can fit into here yet. We'll get there. What I want to do now is ask the user their name. All right, I want to ask the user their name, and there's a way for that. All right, there's a way for that. It is down here somewhere. It is in the sensing place. It's a blue one, and it's called the ask block. You say ask what's your name and wait. All right, it's already filled in for us. That's perfect. So let me run that program. If I click the green flag, it's just going to run this part. This part's just floating around right now. So I click it. What's your name? I type my name, Lawton. Hit enter, and the program's over because it just ran that thing. But my name went somewhere. It went into a special variable right here, this circular thing called answer. All right, it's right here, it's next to the ask block. If you click it, you'll see what's inside of it right now. And that's what I just put. You see it? If you type your name, it'll hold your name. So if I type my cat's name, for example, Alonzo, and click the answer again, now it's been set to that. It's a variable that can change to whatever you put in it. It's connected to the ask block. So right now, if I type my name again, it held that, all right? And so what I want to do is compute this string, right? Hello, comma, space, your name, exclamation point, to then spit back out to the user to say hi to them, yes? So let me do that with join, all right? So instead of apple banana, I want to do like hello answer. Does that kind of make sense? So like, let me retype my name, Lawton. So Lawton is what's in the answer variable right now. If I click it, you can always just like, if you're done with something, you like slide it back. Will go away. But if I say join hello answer, it says right now, hello Lawton without a space. You have to be very careful. It's not just going to add characters. If you want a space, put a space somewhere. All right. Now it's hello space Lawton. I guess I wanted a comma space, right? Comma space Lawton. So that's almost there. I want the exclamation point now too, right? I want it after all this. So I'm going to need another join block. I hope that makes sense. So I want to join like all of this stuff. Can make a bigger block now. Join all of that. So that'll be the hello, comma, space Lawton going right there. And then after all that, I want an exclamation point. Does that make sense how this is going to combine to be hello, comma, space Lawton? Then an exclamation point. It's just a bunch of joins. The first one goes first. It does this little thing, and then we add an exclamation point to the end of it. Does this computation make sense to us? Any questions about that? Because there is technically a second way to do this. Here, let me duplicate this. Duplicate. You can do it in the opposite way. You could be like, put the hello space first, and then put your answer and exclamation point there. Do you see how this is going to compute Lawton exclamation point, and then you can just shove that at the start of hello, comma, space. It'll still do the right thing now. Do you see how you have two options here, and they're both equivalent? It's just like, what do you join together first is now the question. Does that make enough sense? Yes?
How do
I what? Oh, okay, so that you have to run the ask block. So here I connected it to the green flag, so now if I click it, it's going to run that ask block for me, and then you type it. Is that what you needed? Yeah. That'll fill in the answer variable after you type it. Yeah. Any other questions? And so now I've kind of computed this string, and I just want to spit it back out. So let's have the Scratch cat tell us hello, right? He can shout out to us. He can say not this, but this is where you put circular things. You can, instead of just saying hello and hard coding it, you can put this right there. See that? Say whatever I just computed to say for 2 seconds. See that? That's beautiful. So now this is just floating around. This is not anything. This is just, you have two options. another equivalent option. All right. But now this program that I have here is going to, when the green flag is clicked, run the ask block. What's your name? Lawton. And then it computes that string, and it says that whatever it was for 2 seconds. That's my name. If I do my cat's name is Lonzo, it says hello Lonzo. Okay? Does that make sense? It's pretty neat, right? It's a different program every time we run it now because we're getting input from the user. That changes things. That is cool. All right? It's not the same anymore. So yeah, the ask block fills in this answer variable, and then you can use it in a bigger place. All right? Any questions about this one before I go to a different one? All right, so I'll save this so you have it later. And let's do another one. Let's work on numbers now, because we know that numbers do different things than strings. So let's ask the user for a number this time. Scratch will be nice enough to notice that it was a number and shove it into the answer variable as a number. And how about we compute the absolute value of that number? That's like a useful math thing to do. So let's say that the user gives us into the answer variable, because that's where they're always going to go, like the number negative 42. I would like to output the absolute value of that number back to the user, or the sign of the number, whatever you want. But let's do it that way. All right, that's a new program. Let's see here. So I'll just clear everything out with file new. And so yeah, what I want to do is in the ask block, ask the user, hey, not what's your name anymore. What's going to go? What do I want now? Enter a number, I guess. Enter a number. And wait. And then it will go into the answer variable once they've done it. Okay. So like here, let me just click it to run it. Cheating. If I type negative 42, hit enter. Now answer holds negative 42. If I do it again, it'll hold the different value. All right. So I've got a number now in answer. I like to output the absolute value of that number. And there is a little block for that. It's down in operators. Again, you got a bunch of operators that you can do. Down here, you got one called abs right now, and abs is short for absolute value. But you can click this, and you can make it any of these operations. Sine, cosine, tangent. You can do a bunch of number stuff. The default one is absolute value, though. So if I say absolute value of this thing, right now, answer holds negative 42. So if I ask the absolute value of it, click it to run that, it computes the absolute value of negative 42, which is positive 42. See that? And we can just spit that back out with the say block. Say, not hello, but this answer. This fancy computation, compute it for 2 seconds. All right, so this is a program I like to run, not when the green flag gets clicked this time, because there's different events that can start your program. Let's make it happen when we click the sprite that the program is attached to. So right now, the program is just on the Scratch Cat, who is called Sprite1 by default, which I don't like. I'm going to call him Scratch Cat. You don't have to do that, but it's more humane this way. And so in the events, let's make it, let's use when this sprite is clicked. That's another way to start the program. You can have different programs happen, like one way could happen when you do the green flag and do some other thing. Some other way could happen when you click the sprite. So now, whenever I click the Scratch Cat, all this stuff is going to run. All right, that's another event that can start the program. So click him, enter number, and wait, negative 42, enter. And so he computes positive 42 with the abs block and says that for 2 seconds. Click him again. If I type positive 42, it's still positive 42 because that's the absolute value. Yeah. Questions about that one? So answer, Scratch was just nice. It notices that answer was a number because we typed a number. All right, but when we get to Python, that will become very important, this difference between types. So we're just able to do number stuff because Scratch noticed that it was a number. Yeah, that's another fun program. Computation. Negative 1, 2, 3, 4 becomes positive 1, 2, 3, 4. Are there any questions about what this program's doing? Variables are cool. So here, I'll save this one. All right. And yeah, it's nice to use the answer variable. Sometimes we want to do something complicated. So it would be cool to have our own variables. Like let's be able to make an X variable. Okay. So here's what I'd like to do. I'd like to make this program right here. And I'll have it run when the space key gets pressed, because why not? That's another way to start a program. But I'm going to make my own little variable called X. All right, I can do that in Scratch. It's in the orange section down here in variables. All right. By default, you get one variable at the start of the program called my variable, which you usually never want to use that name. So you just like right-click it and say rename it to call it like X or something. That changes your variable's name. Or you can click make a variable, give it some name, call it Y or something. And the default's fine. And then you can delete whichever one you don't want. But here's X. Now I've got an X variable that I can use, right? I can set it to stuff with the set block. Set X to something. So like here, I'll set it to 42 and just run that real quick. So I've got my own x variable that's now holding 42. I can set it to some other thing, 55. Click to run it. Holding 55 now. There's a change block that like adds 1 to it. If you say change by 1, that will add 1 to it. Change by 2 adds 2 to it. Stuff like that. You can show it, print it out really quick just to look at it. You can also check this box to just have it printed up here, just always what its current value is. So like if I change it back to 42, you'll see it holds 42 now. Like that's something you can do. So that's useful. You don't have to like tell the Scratchcat to say it. It'll just always be visible if you check that part. But let's see. Yeah, let's make this program, and there's going to be something wrong with it. Like the goal of this program is the following, right? It's like set x to 44, so it'll shove 44 into x. Show x, so like show it on the screen in the corner there. It's not already shown. Here, I'll uncheck it so it does it that way. And then change it by 1 means add 1 into the x variable, so like make it 45. And then show it again, so show 45, right? That's the program that we're going to see. So we should see it like 44, then 45. Does that make sense? That's what it should be doing. But it's not quite going to do that. It's going to be weird. So here, that's the goal of the program, though. So here, when the space key gets pressed, that's one way to do it. I want to set x, not to 42, but to 44. Then we'll show it down here and all this stuff. Show variable x, change x by 1, show it again. All right. Are you ready? I'm going to press the space key. Boop. I'll do it again. Boop. It's a little small. Woo. We never see it say 44. Does anybody have any ideas as to why? It's always 45. Which means it's running, like, this block, like, it's starting at 44 for sure. It changes to 45 with this one. Like, our code is doing the right thing. Why don't we see 44, though? Yeah. Good. Yeah, it's just any block. I think I said this on like the first or second day. Any block that doesn't have a time attached to it means it's running instantaneously. You remember that? Good. Yeah. So instantaneous to a computer is faster than the screen and the projector can refresh. Okay, so it is secretly 44 for a split second. The computer is just super fast. It's faster than the screen could possibly be. So it really is holding 44 for a little bit. It's just holding 44 for like less than a millisecond, all right? Our eyes cannot process that. The screen doesn't even have time to refresh, all right? Does that make sense? So if we wanted to see the 44, in between here somewhere, we should have like waited. That would fix it, all right? So we can do that. That's in control, right? We can do wait a second, shove it right there. So now it'll be shown as 44, and it will just wait a second, keep it 44 for a while, then do the change and show it again, all right? So I'll press the space key and watch it up here in the corner. 44 for a second. See it there? Beautiful. Questions about why this is going to work now? Why it's doing it that way? It's kind of neat. That's satisfying. See, just watch it change. And then we understand why it's taken its sweet time now because we told it to wait. All right. We good for a completely different topic? All right, so this is just variables. You can make your own, make as many as you need to do your stuff. And let's make cooler programs now, because here's what our programs look like at the moment. They're not that cool. They could be cooler. So right now we've got an event, right, to start our program. It looks like this, something like that at least. And then we have a bunch of blocks that just fit in perfectly underneath that, and that's the programs that we've made so far. Like block 1, block 2, block 3, block 4, they just fit in ever so perfectly, like do thing A, then thing B, then thing C, then thing D. So our program looks like this right now. It's like with however many blocks we've used, it's going A, then B, then C, then D, always. All right? That's what our programs look like. Wouldn't it be cool if we could do this instead? In addition to doing straight line stuff, of course. Wouldn't it be cool if we could do this? I'll do it in rainbow because it's a fun idea. What if we could do this? Ooh, that might be nice. Starting from A, go to either B or C. Pick one somehow. And then maybe once we've chosen one, come back to D. That would make our programs more interesting, wouldn't it? To have that ability. Interesting. And then also, what about this one? A, B, and then come back to A. We don't have that ability yet either. So keep going around and around. So this first one is called a branch. We'd like our program to be able to branch off, do one thing or another for a little bit, because that would give us cooler things, cooler abilities. And then this one, as you might expect, going around and around, it's called a loop, all right? So those are two things we don't know how to do yet, and it's my job to teach it to you now, all right? Are we ready? It's going to make some cooler programs. So I think the easiest one to start with, honestly, is a loop. A loop just repeats. It goes back to previous code. That one's simpler for me to teach first. So let's do that, all right? So here's a silly little program. I will make this exact program, and it will be fun. So this is a loops example. All right, so let me make this in code, and then we'll talk about it, but it's going to involve this repeat block, which will take things that can go inside of it. So I'll just clear everything out. And so I guess my event this time is not when the space key is pressed, but when I press the up arrow. Let's run this program. What we're going to do is we're going to ask the user a question and get a number from them, because that will be very useful to us. I guess actually let me explain loops first. So here, let me just have it disconnected. Do it down here. So in control, you have some things. You have branches and loops. You have a forever loop that just runs stuff forever. And then you have like a repeat block that will run stuff a certain number of times, however many you put here, so like 10 times. And notice how there's spots inside. You can put code inside, and that's the code that gets repeated 10 times. Does that make sense? That's what's going to go on there. So what I can do is 10 times, I can ask the Scratch Cat to like turn a certain number of degrees, and just due to the nature of the way this turn block runs, it'll like take a little while and it will produce animation. So if I do this 10 times, there's going to be like 10 frames of animation, and the Scratch Cat will just move a chunk of 15 degrees at a time. So in total, he will turn, once I run this entire block and it repeats, 150 degrees, but we'll see the progression because he's turning 15 degrees at a time. All right, so if I click this, look at him go. Whee! So it's just going to click, it's essentially clicking the block 10 times as fast as it can. I like that, all right? And depending on the degrees you put here, as I just said 15, if I put 5, he'll spin slower, right? Because every frame he's going to spin a little bit less. Look at him. Whee! Still clicking it as fast as it can, but at the same speed, he's turning fewer degrees. See that? That's so fun and exciting, I think. Make him turn 1 degree at a time. Very, very slow turning there. And so if you make him turn a lot, 25 degrees at a time, it's like he's going too fast. He's going to get sick. All right? So I can set his direction back to, what was it, 90 is the default. So that's kind of cool, right? So apparently, depending on the number that I give there, can I make it exactly 90? Not with the mouse, apparently. Depending on the number I get here, he moves faster or slower, right? He spins faster or slower. So let's ask the user, give us a number to put there. Give me how fast you want the Scratch Cat to spin. That's what I want to do. All right? So ask, hey user, how fast should I spin? Question mark, and wait. And then in the answer variable, we're going to get a number, yeah? We're going to get a number, and we can use that number to mean that's how many degrees you want to turn each little chunk of time. So instead of turning 25 degrees or 15 degrees every time, turn answer degrees every time. See how now the user has control over how fast he's going to spin? Because whatever's being put there is going to be repeated, right? And it's going to turn that many each time. So how fast should I spin? So when I press the up arrow, like 15, or let's do 10, hit enter. So now answer was holding 10, and he turned a little bit slower. If I type up arrow and do 20, now he's turning 20 degrees at a time, and he turns faster. Does that make sense? That's pretty neat. So here, let me like mark this up. So this part, as you've seen, is just how many times you want to repeat the inner code. Number of times to repeat the inner code. And then you can put multiple blocks in here. I just needed one. Like you can do as many things as you want. You can repeat as many things as you want. Like put another ask block in here if I wanted to. Like that's fine. Just like whatever's in there gets repeated. All right. So this will get run 10 times, given what we just typed in up there. So gets run 10 times. Cool. And so you have control now as the user. If I type 5, it'll spin very slowly. It'll turn 5 degrees at a time 10 times. Okay? And you can make them turn 20 times to progress the animation, make it longer. But it's up to you. That's pretty cool. So that's our first example of a loop that repeats code. This code, I only put it once, but it's really being run 10 times. Questions about this? So yeah, loops are cool. Did I already save this one? I don't remember. I'm gonna save it again. All right. So I think what I want to do next is now let's do branches. Let me show you the way to like branch off and do one thing or another. The way that we figure out which side to go down, though, is going to involve asking a question in Scratch. It's like we have to figure out, like, do I go down the B side or the C side? You'll give both options, and then what's going to make it go down? What will make it pick a side is a question. We'll ask Scratch a question. If the answer is yes, it'll go down one side. If it's no, it'll go down the other. That's how we have to do it. All right. So we have to, before we get to branching, we have to talk about how to ask questions in Scratch. All right. So our goal is to be able to branch off and figure out how to go one side or another side. And what's going to branch us is a question. All right. So that'll help us do one thing or another, depending on like what the user gives us, something like that. And so what everything that produces a branch is always a question. So like we can ask this kind of question in Scratch, like, is the answer variable holding 42 right now? Question mark. All right. And if the answer is yes, we have the ability to like do one thing or two things or three things. If the answer is no, we can do something completely different. That's what we're going to be doing, right? And then once we picked a side, we can come back down and do like straight line code again. But what branches us off is a question and the answer to it. So this kind of question in computer science, we call it a condition. It's a condition of our branch. All right? And in Scratch, conditions are pointy things. I'll show you that soon. All right? So in general, things that produce yes or no answers we think of as Boolean expressions. All right, so Boolean is a word named after George Boole, the man we talked about on the first day of class, who invented Boolean algebra. So Booleans, or bools for short, sometimes I'll say it that way, they're just things that are either true or false. They're answers, values that are either true or false. All right, and so true is the yes of computer science, and false is the no. Okay. So like when we ask a question in Scratch like this, like is the answer variable less than 0, like use the less than block or something, we want to like figure out that answer. Scratch will do it for us. And then instead of giving back yes or no, like if we want to do something if the answer is yes, instead of asking for like do something if it's yes, we say do something if it's true. All right? Do something if this is a true statement versus a false statement. So yes means true, all right? And no means false. We'll just have to remember that, right? That's how we do it. So let's see here. How do I want to do this right now? I guess I can show you those blocks at least. Get rid of that for a second. Operators. Here, you see these pointy things? This is a less than operator. It's pointy because it produces a Boolean value. So like if I ask, hey, is 25 less than 50? See how it says true? The answer is yes. It gives back true. That true means yes. If I say, hey, is 60 less than 50 or 65? False. Answer is no. All right, so true is the yes of computer science, false is the no of computer science. Okay? All right, so with that ability of branching, we can redo this program without having to use the absolute value block. Like, remember this one? We use the built-in absolute value, but if we are able to branch, we can make our own absolute value, can't we? That'll be kind of cool. So here's kind of the setup. Right? What we need to do, here's the algorithm for computing the absolute value, all right? Based on whatever the user gives us. So I can get the input with an ask block. We know how to do that. Boop. And then it will go into the answer variable. Like maybe the user types -42. They want the absolute value, whatever they type. And then our job now is, how do you compute the absolute value of whatever is an answer? Well, it depends on whether it's positive or negative. So that's the question we ask, right? So is the input less than 0? This is going to be the algorithm. Is the input less than 0? Question mark. And that's going to become some sort of pointy block that will do that for us. Some sort of condition, okay? And if the answer is true, it means yes. The answer is false, it means it was no. What do we want to do in each case? If the input is negative, that means the absolute value of a negative value is its negation, right? So answer -42 is not its own absolute value, so like multiply it by -1. That will make it positive if it were negative. multiply by -1, yeah, and that will fix it. That will make it positive, and then after that's done, we can like show it to the user. There's your absolute value. It's finished. Just display it. Something like that. All right. If the input was not less than 0, if the answer was no, that means like the answer was like positive 42 or something. In that case, there's no need to multiply by -1, right? That's just already ready to go. So you're ready to display the number. Do you see how if you didn't have the abs block, you could make it this way, but you'd have to do a different thing depending on if it were positive or negative? Does that make sense? Let's make this code now. All right. So the secret is going to be this block. It's if, then, else. Do you see how it has 2 spots for code to run? And then it also has a little recessed spot for a pointy thing. That's the 3 things it takes. All right. So an if, then, else, it looks like this. Is in control again. What it is it takes this. This is where you put your question, the pointy thing. That's where your condition goes. Condition that will either become true or false. Just by being pointy, it's guaranteed to either become true or false. Condition, I spelled that right, yeah? Condition goes here. And it's something that must eventually become true or false. And it will because it's pointy, all right? It's just guaranteed. And then you have 2 slots, right? You got the then slot and the else slot. Boop. I'll call that 1 and 2. And you can put as much code as you want in here, just like for the loops. Doesn't have to be just one thing. And what this one would do, this one is what runs when it's true, right? This gets executed if the condition is true. We'll call it cond. If the condition is true, right? And then this one will get run if the condition is false. It's always one or the other. Isn't that nice? If cond is false, you can do whatever you want, as much stuff as you want on each side. We call these branches, right? So this part is called the true branch. This part is called the false branch. So another name for this is the true branch. True branch. And this is the false branch. Something like that. All right. So in general, this turns into something like this in kind of the diagrams that I've been drawing. So like cond happens first, it asks the question, and if the answer is true, it does thing 1, as many stuff as you put there, and then if the answer is false, it does thing 2. All right, does that make sense? And then once it's picked a side to go down and runs it, it's just over. It's as if it was just like a giant normal looking block kind of thing. So there's room for stuff down here. You could do more straight line stuff after. That's still fine. Okay. So, yeah, if that is the setup for an if-then-else, we need it, right? When the green flag gets clicked or something to do absolute value, you're going to eventually need this, control, and then if-then-else, have a pointy condition. Pointy things are down here in operators, probably less than is the one you need. Stuff like this is the stuff you'll be looking for. But I want you to try this. I want you to try exactly this algorithm. All right, here it is. Try to convert this diagram into code, into a use of an if-then-else block. All right, I'll give you a few minutes to try it yourself, and I think that's going to be good practice for you. And I'll come around and help if you have any questions. And so yeah, before I send you off, so like here's your setup. This is what I want you to do. Get input from the user, check if it's less than 0. That'll be the condition of your if-then-else. And then if it was less than 0, multiply that thing by -1 before you display it. Otherwise, if it wasn't less than 0 in your other branch, just like you're ready. It's already positive or 0. It's already its own absolute value. It's perfect. All right? And so like it all depends. So like answer, if answer was a -42, like the answer is the thing that you're getting with the input, right? That will work. All right? So give that a try. And if you get it done soon, quick, try using variables instead. Like instead of like using answer all day long, you can't reset answer. You cannot set it to new things, but you can shove it into some other variable that you make, and you're allowed to mess with your own variables like x. Okay, so try it that way if you get it the way with answer first. All right, if you get it done quick enough. Are there any questions about the question? So I want you to take that diagram and convert it to code with our if-then-else block. All right, go off, take a few minutes, help the people around you, like discuss if you have any questions, and I'll be here to help as well. There's a way just doing it with the answer, just like multiply answer by -1 before you show it or something. And then there's a way with just a variable. They made this. This wasn't part of the app, right? We're doing it ourselves. You were able to get it go down one side or the other based on the condition. Give you a couple more minutes, and then I'll show you my answer. If you finish early, just play around. It's the best way to learn. Make your own question to do one thing or another. Maybe you can have the scratch cat spin forwards or backwards or something, depending. Very loud. All right, that was my timer at least. Are there any questions that came up as we were trying it? Were we able to all get it? Are there any roadblocks that we encountered? So I'm happy to, of course, share the answer. I want to make sure you got your own questions answered first. So maybe showing the answer is a little cheating. But are we ready to see how I might think about the problem? All right. So, let's see. I think I do need all these pieces, so I'll keep them around. So what do I want to do? Like when the green flag gets clicked or something. Get that input. So that's the very first thing. So that's the ask block, right? Hey, user, give me a number. Enter a number. And wait. And that number will be shoved into the answer variable, yes? So whatever that was, it's now there after that block runs. What next? Well, now it's a question time. It's like, all right, based on whatever that answer was holding, if it was negative 42, then I may need to make it positive 42. If it was already positive 42, I want to keep it positive 42, right? It's just like either multiply by negative 1 or don't is kind of the answer there. And so that all depends on what is the sign of that answer. So I want to check, hey, is the input less than 0? Do one thing or another depending on it. So, hey, answer, are you less than 0? Does that make sense why that's going to be my condition? That's how you can check that. Put it there. And now, in the first part, in the true branch, I can have things to do. I'll put things to do when it's true, when the answer is yes, when it really was negative, because that's going to require flipping the sign, right? Getting rid of the negative. And then in the else branch, I will know if I ever get there, right? It's always going to pick one side and go down another. If I get here, that means the answer to this was false. That means it was really 0 or bigger. So it was already the right number. It was already its own absolute value. Okay? So I just want to spit out, right? In each case, say, not hello for 2 seconds, but say the right answer for 2 seconds. So in the negative case, if it was negative, what do I want to do with answer? I want to multiply it by negative 1. Whatever you were, multiply by negative 1, because that'll make you positive, right? So the only way I got here is if it was negative, the answer was yes. So now make it positive by multiplying it by negative 1. Get rid of that negative sign. And then otherwise, if it was already, like if this was a no answer, if it was false, then it was already 0 or bigger, so it's already good to go, just say the answer for 2 seconds. Does that make sense? Now when I run this, if I type negative 42, it'll go down the first branch because of that and make positive 42 come out. And if I type positive 42 or 0 or anything, it'll keep it positive 42. It won't go down this side to make it negative 42 because the answer was no to that original question. Does that make sense to us? Are there any questions about that? That's how we're going to break down the problem and get it into Scratch. So everybody see how I was able to use this, just one by one, piece by piece, fill it in with the real code. Am I good with that? All right, so I'll definitely give this to you. Feel free to study it if you would like. So there's that. And I guess the last piece of this puzzle is I wanted to show you the cooler way. There's a way to do it with your own variable instead of using the answer variable, and I'd like to show that to you. Here. I'll go down to variables. I'll just, I don't have to click make a variable. I'll just like rename this default variable to x. So I like the name x, that's better. So instead of using answer all over the place, what I could do is I'm forced to use answer after the ask block, right? That's the only place. The ask block is only ever going to set the answer variable. So like after that though, it's fair game for me to use x. So what I'll do is after the user sends me something, I want to do this process. After the user gives me something, it's forced to go in the answer variable, which I cannot mess with. But I can immediately take it and put it into my own variable. Okay, that's what I want to do. So hey, set x to be whatever was in answer. Does that make sense? Why these two blocks, like we'll get the first thing, like the first one will put some new value in answer, and then this one changes x to hold whatever answer held. Do we see that? It was moving it in there, copying it in there. Does that make sense to us? So now it's sitting in x. And we can mess with x all day long because we have these options here down here. We can't do it sadly, for answer that way. And so now you have some cooler options. Watch. Now instead of saying answer everywhere, I'll use x. All right, first of all, I can get the program to be the same if I just swap answer with x everywhere. I hope that makes sense. So here, I'll check x. Right now it's set to 0, but it'll get set to whatever I type here. Negative 42. See how it was negative 42? And it prints out positive 42 now. If I type positive 42, I'll make it negative 42. It's just shoving answer into x and then using x to compute the result. We good with that part? That's just a copy of what we are already doing. It's not much cooler. But we can make it a little bit cooler. I think I want to show you that you can modify your own variables. Like if x was 42, I want to change it to positive 42. That'll be nice. Put the opposite value in that variable now. That's where I'm going with this. So instead of saying the answer down this branch here, the answer down this branch is this though, right? X times negative 1. We want to flip the sign of whatever is in x. So to do that, I want to mess with x itself. I want to set x to be whatever it used to be, but now times negative 1. That's what I want to put in there. Do you see that? That's what I'd like to do. So in order to do that, it's just another set x. Set x to be whatever it used to be times negative 1. Looks a little weird, but this side's going to run first, get that answer, shove it back into x. You see how that's going to change x to be its own negation? That's kind of cool. And then we're ready, right? X holds the right answer now. So now we can just say x for 2 seconds. It will already hold the right answer after that process is complete. So I type negative 42. You'll see the current value of x there. Boop. I type negative 42. It did hold negative 42 for a split second here. I can stop. Just show that to you. I'll wait a second before it does its option, before it does its answers. So here, negative 42. So it really is set to negative 42, but then it picks the branch to go down. It runs this block to set it to positive 42, shoving the new answer into x. Says x for 2 seconds. That's a little bit interesting, right? That's different. Are there any questions about why this is going to do the same thing? So now we're messing with our own variables. That's more powerful, all right? We can go places with that. We good? Because there's one last thing I want to do to improve this code is, do you see how this say x for 2 seconds, it's at the end of both? It's kind of repeated. I could do better than that, right? It's just the idea of this if then else now is just like either mess with x or don't mess with x. And then it says it always. It like spits out the answer after that, which is just x. It's always an x now. So why don't I just do this? Why don't I just bring the say x for 2 seconds down here, like after it's picked the side to go down. Just do nothing in the else. That's fine. And then I'm ready. Do you see how that gives me less code now? But it does the same thing. Watch. So now the job of the branch is to just mess with x. Either mess with x or don't mess with x. And then once that messing is finished, it's just always the answer is in x. Say it. Shout it out. Does that make sense? Well, that's a little different. Questions about that? You can have an empty else. That's fine. Just do nothing if it was false. So you didn't need to do anything if we're doing it this way. So it's like pick the branch to go down, do one side or the other, and then once that's all done, once you pick the side, then like the final answer is in here. Is like always do that one. Is that parsing in our brains? Very cool. If you have it like this, where you don't need to do anything when it's false, there is just an if, which does exactly that. So instead of having an if else, I could have done this. I just like could have just been an if by itself. If x is 0, mess with x. Boop. Just like only if it's true, do something. Does that make sense? If it's false, it'll just skip it over completely. Like this is an if-then block only. If x is negative, make it positive. Otherwise, it was already good to go. Don't do anything at all. And then just like immediately go to here. So negative 42. Watch it change. But this one fires. It runs the inner part. Made it positive 42. If it was already positive 42, it's just going to skip over after it notices this. Like, all right, yeah, I don't need to do any of this because it wasn't less than 0. Just immediately skip to here. And so that, I think, is the cleanest way to do it using extra variables. Are there any questions about that? So let me give this to you too. And yeah, if we're good, do shout out if you have questions. But if we are good, the last thing that I want to do, make sure you've done attendance. I think I've forgotten to stop that. I'll stop that in just a second. But the last thing I want to do is talk to you about your next programming assignment. All right, there will be time in class to get started if you would like. So here is your next assignment. I will release it now. Boop. This one will be due in just a week because there's no holidays, so a week and a day. All right. The reason you had extra time for the first one is because there was a holiday. All right, so remember that I've got two options for programming assignments. So either you've never programmed before, this is your first programming class, or you've programmed before. I've got two options again. All right, so if you're in the group that has never programmed before, here is your program. I'd like you to make a cute little teleportation program. All right, this is going to force you to use branches. All right, so here's what I want from you. If this is your assignment, I'd like you to teleport the Scratch Cat or somebody else. You can pick whatever sprite you want. It doesn't have to be the Scratch Cat. But I want your program to run when the sprite is clicked, so not when the green flag gets clicked. All right? So a little bit of a difference there. I'll mark you down if you do it when the green flag gets clicked. So when the sprite gets clicked, your program runs, and then you do the following. So what I want you to do is once you start the program, once you click the sprite, it should teleport magically your sprite to somewhere on the screen, just like there's coordinates, right? There's blocks that say random. Go find them, and that will teleport your sprite somewhere. And then the idea is, like, once you've clicked your sprite, you've run your program. Either your sprite is like up here somewhere, like randomly moved up here, or maybe they randomly moved down here. I want you to have your sprite notice where they are. All right. I want you to have your sprite notice where they are. There's a coordinate system here, and so there's a line that you can draw in Scratch. Boop. If I move the Scratch Cat, see how his position changes? There's like X's and Y's. So if the Y is positive, he's up here. If the Y is negative, he's down here somewhere. See that? So I want you to hook into that. There is, where is it? Is it in looks or motion? There it is. There are variables about where your sprite is right now. X position and Y position and direction. So if I move the Scratch Cat over here, X is negative 182, click it, negative 182. If I move him over here, X is 157, click it again. This variable always holds where the sprite is, X coordinate and Y coordinate. All right. So what I want you to do is, after you teleport your sprite magically, I want you to hook in to that variable, I guess the Y one, and figure out if the sprite is in the upper half of the screen or the bottom half of the screen, and have him print out that he noticed that. All right, so like if he's in the upper half of the screen after he teleports, say something to that effect, like I'm in the upper half, or I'm above the Y equals 0 line, something like that. I'm in the upper half. That's going to be your program. If he's below, it'll say, notice that with an if, and then be like, I'm in the bottom half of the screen. It becomes sentient, right? I'm in the lower half. That's essentially it. So you click the sprite, teleports, and then figure out which side of the screen you're on, the top or the bottom, and then print something out, having noticed that. So do you see how that's going to force you to use a branch? Do one thing or another? All right, so that's what I want from you. I think just the rest of this is text saying that. It's like, say something like, I'm above I'm in the upper half, I'm above the middle line, whatever. If you do that, or below if they're below. All right, so you can say something different like I wrote, and you can make it fun if you'd like. Like, there are sounds that you can play. Maybe there's like a pop sound that you can play whenever they teleport. Like, that's a thing. Have you found those already? That's in sound, right? I guess the default cat sound is meow. Oh, that's really loud, sorry. But yeah, that's a thing that you could do. You record your own sound if you'd like. I will 100% be turning this volume down for the future. Don't know why that was the default. All right, cool. I hope that makes sense. So that's something you could do if you'd like, but like this is the real stuff that you need. And so you're required to do the following, right? In addition to starting when the sprite gets clicked, you need to use a block that contains the word random to do the teleportation. I think you'll find it. And then you need to use an if-else to like notice if you're above or below the Y equals 0 line. Okay, so that's it. You can add more stuff if you'd like, but here is just an example of me showing you kind of what I want from you, if that is at all confusing. So I've hidden the code, of course, and I've done it differently, but like this is kind of what you want. Like you click it, he teleports, and like he'll notice where he is. Like I'm above the line, I'm below the Y equals 0 line. That's kind of what I want from you. But obviously I did it a little bit wrong and I didn't show you the code. All right, you have to do it when the sprite gets clicked and all the other stuff. But that's a hint for you. Okay. Are there any questions about this assignment? That's for those of you who have not programmed before. All right, it'll be due in a week. And then for those of you who have programmed before, I'll talk about how to turn it in just a second. If you have programmed before, here's what I want. Chapters 1.3 to 1.4 of, if you're doing my default assignments at least, these chapters of the book, and I want you to do exercise 5. All right, it'll be a fun one. And yeah, if you would like a custom assignment, if you are a programmer, I can give you a custom assignment. Talk to me. But for both of you, what I want you to do to turn it in this time is not to show me a screenshot, because I need to see it working, right? So to turn in your assignments from now on, I want you to upload videos, all right? I would like you to upload a video of your program running, show me your code. It does not have to be long, but I want you to try it a few times so I can see all the ways that it's working. It doesn't have to be like a minute is fine for the video. To show it to me, show me that you understand what your code is doing, talk me through it real quick, all right? You can record it in any way that you would like. I can help you if you're having trouble. I prefer this program called OBS, but Zoom, you probably already have Zoom on your program on your computers at home, that will record for you. There's ways. You can record it on your phone if you need to, though. But ask me if you have any questions about that. I can help you. And yeah, from now on, videos will be required. If you need some time to get your microphone set up at home or check something out from the library, like a laptop, to be able to do these in the future, for this one assignment, I will allow you to upload a screenshot. If you just cannot get the video working. That's just this time. Yes?
Can we just do it with the note blocks?
What's that?
Explain the code within the notes.
I want a video and I want your voice.
Okay.
Yeah. Sorry. That's what I want, because that proves to me that you understand it. Okay. Yeah. So that's why I need it that way. Because AI could be writing stuff if you just type it out. All right. So, yeah, video recordings will be required for sure next time. So make sure to get everything working before then if you can't do a video this time, okay? And then same for the programmer people. I want a video where you go through your program, talk to me, I want to hear your voice, and upload it, all right? If you can't do it, give me a screenshot and some words just this time. But from then on, I'll give you 0 if you do it that way, all right? I want a video and your explanation, proving to me that you understand it from now. Questions about that? Yes?
So for the scratch one, you don't need us to
Explain. Yeah, I want to hear your voice. Yes, please. All right. Yeah, any other questions? So it doesn't have to be long, though. It's not going to be a lot of code, but it'll take some time to figure it out. It's show me what's happening, walk me through it, and that will be your submission. All right. And yeah, just keep track of the due date. I think that's everything I wanted to say. We good? All right. That is officially all that I have for us today.